Okay, so we got that, and then we need resources. Notes. I have that.
Oh, I didn't.
Why are you putting yourself right? It's just miserable. He goes, I talked to 5 doctors yesterday, and each and every one of them said it could.
Okay, so if I go here
So we should.
and look at
And like the alternate, but actually.
And I really should have done that because it really felt over when I had done it. Hurts me through it. It's okay, this makes sense.
Which is really good for my mom.
notes. Yeah. Notes. All right. Okay.
No, it's like crazy. I feel like it's just stuck in my bike right now. I can get off. But also like don't.
Ah, that's what I needed. Okay. Yeah. All right. So if I go here to resources, assignments.
A gym locker. Just a bulk cutter. No, not one of those. It's like 40.
This.
Do a picture. I saw somebody who was on a bike and they just went right by me and I was like, oh, hi, Danny. Oh,
Control
that's
zero.
terrible. I'm sorry. It's
Um,
like this, here's the cord. Here's the keys.
right.
Oh, yeah.
But this
He was
piece
one of
attached.
those.
Oh, yeah.
And this is the latch.
Yeah.
Okay. Oh yeah.
Right, I
Standard
told you.
deviation, which is what I
I
thought.
totally worked at a place that has like 8 of them.
But I don't want to buy one.
No,
And
like I can ask my uncle if they'll.
P value, right?
Just, I'll rent it. I'll rent it.
Yes.
We don't actually rent it, it's just the store.
All right.
I'll rent it.
So I know what's going on here. Good thing I know what's going on. Yeah. Okay. So here we are on the 11th of July. And we're looking at, again, I haven't changed this schedule, but I did change it online, at least in the textbook publisher thing, that homework set 11 is due today. Homework set 12 is going to be due on Monday, and that's all that we're going to be having on the exam. Now, it's kind of crazy when you think about it. In the first exam, we had 4 homework sets. The second exam, we have 5 homework sets. And this exam, we're only going to have 3 homework sets. But, yeah, it's actually a positive development. Less and less information as we go, but no. These things, as we've seen, each problem has 6 parts, and so then, or 5 parts, and so then and each of those parts has parts inside of it. So just one hypothesis test is a huge deal. And what's also going to be on the test are the confidence intervals. So put that all together, and yeah, we're going to have plenty to do for the exam. We'll have a review day, of course. And then more things. So we'll start though by just talking about hypothesis testing. And I don't think it would hurt us to do some more practice with this in the sense of, how shall we say this? All the different kinds, okay? Homework set number 11, having to do with 2 kinds of hypothesis testing. But let's back up just a little bit. If we say hypothesis testing, what is our goal in hypothesis testing? If if I were to say in a general statement, what is the goal of hypothesis testing? What would you tell me? No. Really? To prove a difference. Okay, the goal of hypothesis testing is to prove a difference of some kind, which is not the null hypothesis, it is the alternative hypothesis. Okay? So our goal all the time is to prove the alternative hypothesis, which is a statement of some kind of a difference. There's something that we're saying is different somehow, and we want to prove that it's different. And again, what this looks like. Let's just take an example. Percent. Let's just type the word poverty and see what happens. The official poverty rate is 12.7%. All right. Poverty rate, La Crosse, Wisconsin. 15.2%. Okay, well, that was a couple of years ago, but let's just pretend that that's what's going on. All right. Now, so let's say that we've got 15% in La Crosse County. Poverty rate in La Crosse County is 15%. Okay, so let's say that we have, let's do a survey of Western students. And let's say that we have 300 students. And we find that it's 60 poverty. Okay. Now, of course, these things, when we say how do we define what is poverty? We're not asking that question right now. We're just pretending that we know what it is. And so then we have this information. Okay. So now we're looking at this and we want to do a comparison. All right. So if we do our comparison, we're asking a question, is there a difference? Is there a difference between Western students and La Crosse County? Is something different about this number, this group of people? Okay. And we're talking about putting people into a category. And so then we're dealing with a specific kind of problem. We have three different things that we can do. We can either do what? Proportion, mean, standard deviation. And so if I look at this problem, how do I know it is a proportion problem? It's not because it's a sample. Everything has samples. No, because we're always comparing things. How do we know that this is a proportion problem? Okay, we're talking about a percent, but specifically when we're measuring something, no, it's not that we're measuring people, it's that we're putting people into a category and we're asking them a yes or no question. Okay, so when we're looking at a proportion problem, what we observe is the number of people who said yes about a thing, or the number of people in a specific category. So proportion problems are asking what category are you in, and it's a certain number out of a total survey. Okay, that makes it a proportion problem. All right. How would this be different from doing a mean or a standard deviation problem? If I'm talking about a hypothesis test for the mean, then I would be actually asking people for a number. Like, how many footballs do you own? Or how many hockey sticks have you broken in your life? Or whatever else. If I'm looking at mean or standard deviation, I have to be asking people about a number. What's your cholesterol level? How much money have you spent on breakfast food? Okay, I'm asking for a number if I'm doing mean or standard deviation. When I'm doing proportion, I'm putting people into a category and I'm asking them, are you or are you not? And they say yes or no, and it's a certain number out of a total survey. That's a proportion problem. All right. And that, of course, is important when you're working on a test and you say, okay, which thing am I looking at? You need to know which kind of thing it is in order to know which formula to use, what table to look at, what steps you're going to follow, all that stuff. Okay. So if it's a proportion problem, which this is, then I should look for a p hat. What is the meaning of the symbol p hat? Sample proportion, okay? So p hat is going to give me a proportion from the sample. So, Eric, can you tell me how I would find p hat in this situation?
X divided by n, so 60 divided by
60 divided by 300, okay? So what is that? 0.2. Okay, so I have a p hat, which is 0.2. So I need sample numbers. I also need a population number to compare that to. What's the symbol for population proportion? Just P. When I get to it, what table am I going to use for this? Could use, well, it's either E or G, right? But what statistical symbol am I looking for? When I do proportions, I'm going to be looking for a z-score. And as it turns out, that's where? Where specifically? Nikki, you're going to tell me, aren't you?
Yeah.
Specifically, where on table F am I going to find a z-score?
The DF column all the way down where it says Z.
Okay, all the way down at the bottom of table F. That's a good place to look for my numbers, okay? So, as soon as I say this is a proportion problem, okay, then I'm going to think, well, there's a p hat involved, there's a p involved, and if I need to look something up on a table, I'm going to go to the bottom of table F to find the Z for this problem. Okay, so I know all those things. All right, so let's see if we can make this happen one step at a time here. It's possible, maybe, it'll happen. So we start with Amanda. Amanda, what's my first step in doing hypothesis testing? No, not yet. Do you have your piece of paper where I give you the steps for hypothesis testing? Okay, let me just announce this. Everybody should have that piece of paper out in front of them right now. Steps for hypothesis testing. Okay, from now until the end of the class, you should have that piece of paper out in front of you so you know what the steps are. Okay, and I don't think less of you, Amanda, for not having it out. So the first thing is state the hypotheses and identify the claim. All right. So, if we were actually doing this, we would have to think about this on our own and come up with it. However, since this is a class, normally you're going to be given what that claim is going to be. But if we just think about this a little bit, we're trying to prove a difference. So Danielle up in the front here, can you tell me what would be a reasonable claim at this point?
That poverty within Western students exceeds lacrosse.
Yeah, it makes sense because we came up with a 0.2, which would be 20%. And so it makes sense that we would ask the question, is it true that poverty in Western students is higher or exceeds or is more than La Crosse County, right? So that's what we're going to say. We're going to say, is Western poverty higher? Okay, that makes sense. So, Amber, I want to know what my null and alternative hypotheses look like.
P for the null hypothesis, P is equal to 0.15.
Okay.
And the alternative is P is greater than 0.15.
Okay, that's right. So we know the sample number is 20%. What we don't know is if that's significantly higher than 15%. So what we have to do is we have to think about the possibility. If things are just like they are in La Crosse County, this would be a 15, but it's not the same thing as it is in La Crosse County. It's higher. Then the question is, how much higher? Is it significantly higher? Okay. Or is this just a random fluctuation? That would be the other possibility. We only talked to 300 students, or had information for 300 students. We didn't get everybody's information. We don't know. And that, just to give you a thing here, if, for example, somebody does a census of La Crosse County and they talk to everybody and they get the poverty rate from talking to everybody, then we don't have to do this. We know what the rate is. If we talk to everybody, then we're fine. But what we're doing here is just from a sample, and we want to ask the question, does the sample give me enough information to make this call? All right. So, Nikki, can you tell me what's the next thing on my hypothesis testing?
To find the critical value.
Okay. I want to find the critical value, and you already told me where to find that. We're going to take alpha of being, let's just say 0.05. All right. So, Humphrey, can you tell me what my critical value is for this problem?
1.960?
Actually, no, because 1.960 is not under one tail 0.05. If I look at this right here, I draw my picture. This is one tail. And if I say it's one tail 0.05, then that means this right here is 1.64. But you were on the right page, and you went down to the right part. You just didn't quite go over to the right section. Okay, so that's partial credit right there. Okay, you were looking in the right place, but not quite exactly the right place. So this is a one tail 0.05, critical value is 1.645. All right. So Emily Grenier, what's next? Okay, we want to compute the test value. Can you tell me how to do that?
P hat minus Q over the square root of P times Q divided by N.
Okay, so let's see what happens. Oh, and what's on the left side of that, Emily?
A Z.
A Z, that's right. Our test value will be a Z-score. Oh, I suppose I need to do this too, don't I? All right. Allie, what do you got?
2.43.
2.43. Okay. So, Allie, what do we do with that?
We make a decision to reject or not reject.
That is correct. So, Allie, tell me what we're going to do.
I would reject.
The null hypothesis.
Oh.
Yes, you will reject the null hypothesis. Okay? The word reject is the right word, but it's followed by the null hypothesis. Okay? And the reason why you did that is because the test value is in the rejection region. So we reject the null hypothesis. Okay? So Taylor, what does that mean?
There is enough evidence to prove that Western poverty rate exceeds 15%.
Or is higher than? Say that, or is more than, any of those things, all right? So when we say reject the null hypothesis, we're saying there is evidence or enough evidence to prove H1, which is what we want. So we say there is enough evidence to prove that Western student poverty rate is high. Okay. Now, when we are going to say the entire conclusion here, we're going to make sure that we have all the different things covered by going through these 7 things. They're listed on here. Okay? And once again, people get really tied up in knots about this. I don't want you to be tied up in knots. I would like for you to get it right. But this is the most important part of anything we just did. We made the right conclusion, and we said we're able to prove a thing. The way we phrase it with these 7 steps, this is one question on the test. Give me all 7 steps. And if you miss one of these questions, it's 1 point off your test. Okay? But if you get this wrong, and you say there's not evidence, that's like 15 points off your test. Okay? So make sure that you know this stuff. This other thing is just detail. Right? So, see if we make that happen. Taylor, can you go through the 7 things from my list here?
I don't have one.
Oh, well, I have an extra.
You just want me to list them all?
No, I want you to tell me for this problem what those answers would be.
So with 90, with 95,
Yes. With 95% confidence.
there is enough evidence to prove that the population proportion of Western students
Correctly speaking, we would say the population proportion of poverty for Western students. Okay.
is higher than the poverty percent of lacrosse.
Yes, question.
I have a question about the confidence percent. So the
Okay, I'm going to stop you right there. We're doing hypothesis testing. We're not doing confidence intervals. When we're doing hypothesis testing, this number is 1 minus alpha.
So like,
Okay? This is not confidence intervals. So the number I put right there is 1 minus alpha. Okay. All right. So there are a few things that we can say about this situation. One of the things that we can say about the situation is clearly we were way past that 1.645. So when I said alpha was 0.05, I could have made that even smaller, right? Because if I had made alpha smaller, I could have gone out farther to the right. Could I have used an alpha of 0.01? Taylor, what do you think? All right, what would happen if I tried? Let's find out. Abby, what would happen if I used an alpha of 0.01?
the infection region will change.
It would. Can you tell me what it would be?
It's like 0.01.
0.01, I did.
2.326.
2.326. Would that still give me the same conclusion? Yes, it would. Okay. So then the next question that I have is, how far out could I go? And so what I'm going to do is I'm going to treat alpha as a variable. If I ask the question, what could alpha become? What would be my possible values of alpha? The name for this thing is called p-value. And what I'm going to do in order to find my p-value is I use the test value first. I have to have a test value. And the second thing is I'm going to find the area of the tail. So I'm switching this thing up a little bit. I'm going to cross out this picture. I'm not going to use that picture. I'm going to use a different picture now. 0 is still in the middle, but now out here is my 2.43. And I want to know what is this area right now. If I have a 2.43, I want to know what that area is. Well, I can do that with z-scores, because if I go back to table E, I can figure that out. So now what I want us to do is to take a look at table E and see what it says. Okay, table E, I'm looking at z-scores. So Natasha, what do I see when I look at 2.43 on the table? Okay, and then my next question is that telling me the area of the tail? No, it's not.
Would be 1 minus that?
It would be 1 minus that. So the area of the tail is 1 minus 0.009, or sorry, 9925. So that area is 0.075.
So if it was left tail, you would leave it though, right?
That's correct. And I'd be looking at a negative number. Now, Abby told me that I could go out to an alpha of 0.01. Could I even go a little bit smaller than 0.01? Yes, I could. I could go to 0.0075. This then is the p-value for this research question. So what you might see then, I don't want to erase anything. Oh well, I'll erase this. Cross it out, I'll just erase it. Okay, with the cloth, not the eraser. So this is what you would see in a research paper. The proportion or of poverty at Western is higher than across county. E equals 0. So in a research paper, they would be telling you their conclusion, and then they would give you the p-value, and that would tell you that there's a very small chance that this is just a random fluctuation. This would be telling you that we are pretty confident about this result. It's not just 95% confidence, it's not just 99% confidence, it's even more than that because that has a p-value that's really small. Okay? So what we say then is, if p-value is less than alpha, reject
That means there's a very small chance of what?
that it's a random fluctuation. Poverty and health outcomes among people living with HIV, limited resources and competing needs. So then what does this have when they have expenditures on food relative to alcohol and tobacco products? Something going on here. I don't know what it is. We're not going to worry about that. We're just going to say, hey, wow, do you guys have a p-value in here somewhere? Defining statistical significance as p less than 0.05. Hey, guess what? That's what we do. P less than 0.05, p less than 0.01. They're all this. Currently drinks alcohol. Use other non-alcoholic drugs. Received food stamps. Lacks transportation. We're not going to worry about all this stuff right now, but this is what it looks like. When was this research done? Drum roll. 2015. So this is not very long ago. And this is what they're doing. They're using p-values to show you how confident they are about their results. If we have a really small p-value, then that means we're really pretty confident this is not just a chance thing, but there's something actually different here about this, whatever it is.
Are you doing this on the test? You doing this stuff?
That's a great question. I'm not sure right now. Okay, because I had to cut some things out, would I leave this thing in? I'm not sure. I'll let you know. Okay, but now I'm going to tell you something that's not going to be on the test. Well, wait a minute. Anyway, I'm just going to tell you something. How about that? Remember that I told you that confidence intervals are often important in this situation, right? I'm not going to cause you to go through the process right now, but I am going to say the confidence interval is going to tell me something. What does the confidence interval tell me? What is the purpose of the confidence interval? Evie, can you tell me the purpose of the confidence interval? Not happening. Casey, can you tell me purpose of confidence interval? It uses a sample to measure a population, okay? Do we have sample information here? Yes, we do. We have this 20% number. The 20% number came from the sample. What would that tell me about the population? P hat is 0.20. From there, I could create a confidence interval. Now, I'm not going to require that of you right now, and I won't require it on the test either, because we already, or I'm sorry, it is on the first part of the test. Okay, so yes, we want a confidence interval for this right now. Oh, can I help myself? I think I will. I'll just tell you what it is, all right? The confidence interval for this problem would look like this. Okay, this is the confidence interval based on this sample, 60 people out of 300. This I'm getting for my confidence interval. Are these numbers higher than 15%? Yes, they are. So that it means the same thing as what I said over there. The proportion of poverty of Western is higher than La Crosse County because this confidence interval is bigger than 15%. So by using the confidence interval, I can draw the same conclusion as I did going through all this stuff with all these test values and critical values and everything else. I don't really need that if I have this. My confidence interval will tell me the same. So some people say this is actually better because it's giving me more clear information.
So the confidence interval is bigger than P in all purposes.
No. If, well, this is a better way to say that. If the confidence interval does not contain P, which it doesn't, okay? In this situation, it's greater than. We could have situations where it would be less than, right? So it's just that the 15% is not in the confidence interval. So 15% is down here, this one is up here, because it's a greater than thing. It would also work if it was a less than thing. All right? So, so we've kind of beat this horse, as they say, sufficiently. So now let's talk about a T thing. We want to prove a difference, but we're going to be talking about something else here. So we're not going to do p-value here. We're just going to do a regular thing. All right, so let's talk about something else. Let's do basketball. Time spent playing basketball. By 10 to 15 minutes. And let's say that the national average, well, and let's say it's in a particular kind of club. It could be Boys and Girls Club or something else, right? So the national average, let's say, is 2.2 hours. And let's go to Decorah. I always do these things in lacrosse, so let's do it in Decorah, see if they're different. So I go to Decorah and I talk to 28 kids. And I find that the mean is 1.8, and the standard deviation is 1.2. Okay. Now, Casey, what do you think would be a reasonable claim to make right here? Okay. Danielle Koch, you want to give me a try? Okay, Taylor?
Say that time spent playing basketball by 28 kids is less than the national average of 22.2 hours a week.
No, sorry, that's not correct. I don't actually care, well, I mean, in some sense, I don't actually care about these 28 kids. What I care about are all the kids in Decorah. I just chose these 28 out of that group. So what I want to try to prove is that the population mean of basketball playing time of kids in Decorah is less than the national average. Okay? Now, most times, like I said, on a test, I would actually tell you that claim. All right, but I'm just wanting you to think about how that, where that comes from. So I'm going to ask the question, is the population mean of basketball time in Decorah less than the national average? Okay, so that's what I want. Casey, can you tell me what my first step is for hypothesis testing? Okay, so can you tell me, Casey, what would be my null and alternative hypothesis? If not, okay, Danielle, can you give me an idea about my null and alternative hypothesis? Okay, but specifically, what thing am I going to write down? I'm not just going to write the number 2. No, sorry, unfortunately no. We're not talking about proportions anymore. We're talking about a mean. Mu, okay? That's correct, okay? So I'm going to have mu is equal to 2.2. Mu is less than 2.2. Why do I have mu instead of p? So I'm talking about the mean. I'm talking about asking kids, how many hours did you play? I'm not saying, did you play or did you not? And it's not out of something where I'm saying this number of people out of a total number of people. It's the number of hours is my data. And so I have a list, 28 kids. I asked them, how many hours did you spend playing basketball? I wrote those things down. I found the mean and standard deviation. That was my sample information. Okay? So what I have here, mu, Eric, what's the meaning of the symbol mu?
That's your mean. I don't remember if it's the sample or your population.
Okay. Can somebody help Eric out here?
Population.
Okay, mu is the population mean. What's the symbol for sample mean? X bar. What table are we going to use for this? F, and we're going to be looking at values of t. Right? So, Eric, what's my next step in hypothesis testing?
State the hypothesis.
No, we did that already. What's the next thing?
Find the critical.
Okay, I need a critical value. All right, Amanda, where am I going to look for my critical value? I am.
You didn't give us an alpha, did you just use 0.05?
That's correct. So I did not give you an alpha. We're going to use 0.05. So Amanda, where do I look for my number? Did you say 1.703? Okay. So 1.703 is the number that you have there, but then you said it needs to be negative, right? Because it's less than, then that means we're looking at a negative number, a negative 1.703, and we want a left-tailed test. Okay, so far so good. All right. Danielle up here, what do we do next?
And compute the test value.
Okay, so how do I do that?
You take t equals x bar minus mu over the standard deviation divided by the square root of n.
Okay. All right, so let's see what that comes out to be. Oh well. Hmm. Hmm. Ooh, this could work. All right. Amber, you got a number there?
Negative 1.764.
Negative 1.764. Okay. So, Allie, what happens next?
I just have a quick question.
All right.
So did you just say, because I came up with positive 1.761?
Nope.
So is it, do you just make it a negative?
Nope. The sample mean is 1.8. The population mean we're comparing it to is 2.2. Okay.
Okay, so what was your question?
So now what do I do? I do. All right, Emily Grenier, what does that look like? Why? Okay, the test value is in the rejection region, so I reject the null hypothesis. So Emily, what does that mean?
That means that there is an evidence to support the alternative hypothesis.
Okay, there is evidence to prove or support the alternative hypothesis. So then we would say, with 95% confidence, there is evidence that the population mean and what is it that we're measuring?
Time spent playing basketball plus international language.
Almost,
Decora.
right? Of time spent in basketball in Decorah is less than national. Now, as it turns out, if we had a computer, we could find the p-value for this situation as well. Because right here, this negative 1.764, that's taking us farther down. So alpha 0.05, we could make alpha even smaller than that if we wanted to. And if we ask the question, well, how much smaller can we make it? If we have a computer, it will tell us that the p-value is 0.46 or 0.046. So that's a little bit smaller than 5%, fine. We're not going to worry about that though. We're just going to say we have evidence to prove this and we're good with that. As you may be able to understand, we could also make a confidence interval because we have sample data. We could make a confidence interval. But we're not going to worry about that either.
Can you review this stuff on Monday?
Yeah. Yep. All right. So let's take a break right now, and then we'll come back and do the standard deviation.
And that'll be 410.
Just these.